On this episode of the Embedded Insiders, Brandon and Rich discuss recent findings that show 96% of manufacturing and automation companies who responded successfully to the COVID-19 pandemic had Industry 4.0 technology in place. But how? Then, Colin O'Flynn, CTO of open source security tooling company NewAE Technology, joins to explain the growing risk of side channel attacks to IoT devices. But the side channels themselves may not be the biggest challenge. It might be convincing engineers that they should care, then teaching them how to look for not so obvious vulnerabilities. Finally, Assistant Editor Taryn Engmark wanders into the abstract world of 6G edge networking, where wireless connectivity technologies abound. How will we support all of the different options on a unified infrastructure? ETSI is working on a solution: Reconfigurable Intelligent Surfaces.
Hello and welcome to the Embedded Insiders. I'm Brandon Lewis, Editor-in-Chief of Embedded Computing Design, here with Rich Nass, who's the EVP and Brand Director of Embedded Computing Design and Open Systems Media. How are you today, Rich?
I am okay. Yesterday was a great day. Today is a so-so day.
Oh, every day is a great day at Embedded Computing Design. You must have been, you must have been doing more of the Open Systems Media stuff.
That's right.
Anyway, we obviously cover two of the big areas that we cover in embedded computing design are industry, automation, manufacturing, etc., and the Internet of Things. And the convergence of those two things is Industry 4.0, or the industrial Internet of Things. And I was doing some research the other day, and I came across a report from McKinsey & Company, which I thought was so interesting that it was relevant bringing up here. The report looked at how companies have fared in the manufacturing sector since the pandemic. Now, obviously, there are a whole lot of reasons that sector in particular has been hurt. Number one, you can't have any workers go into your factory if there are shutdowns in your community. And number two, you can't get supplies from other places and then ship supplies out of your factory because also everything was locked down. So how did they fare? And, I think the easy answer is not well, and really nobody fared very well. But the report shows that certain companies were actually able to fare better than others because they had Industry 4.0 technology implemented. On the flip side, the report shows that people who didn't have any Industry 4.0 infrastructure in place really didn't have the ability to even respond to the crisis. And it shows that out of more than 400 different companies around the world, 96% that were able to effectively respond to COVID-19 had Industry 4.0 use cases scaled across their multiple facilities, and only 19% who were able to effectively respond didn't have any at all. And some examples were, there was a consumer packaged good company who had digital twins running, basically a digital clone of their manufacturing infrastructure. And they started running simulations of what would happen if, say, tomorrow nobody could come into work, or next week they didn't get some of the parts into their facility, and so on and so forth. And it sort of worked. They were able to get through rather efficiently, balancing out their staffing, running their equipment and machinery at certain times versus others, just really optimizing. So somewhat telling.
Well, what I would say to that, first of all, anybody who listened to my advice would not be in this boat, because I moved right to Industry 5.0 when it was available. So you don't have to worry about having people in your factory because you have robots, or what we call cobots, running the factory. It certainly doesn't solve the issue of getting supply in, but as far as having people in the factory, done. You got these robots bouncing around, taking care of everything, with the limited number of people are in there, no problem at all. The inbound supply chain is definitely an issue. And somebody told me just last week, if you're not done with your Christmas shopping by now, you're in big trouble because there's not going to be anything left on the shelf.
Last week,
Yes.
I haven't even started thinking about Christmas. I live on a 2-week time horizon. But no, yeah, I actually thought the same thing. And this is one of those places where it'd be great to hear from the community about what your, where you are with your Industry 4.0 deployments and how you think that you could navigate through this type of situation or how you actually fared, because Rich and I live in an adjacent reality where we spend all of our time talking to, reading and writing about, how things are happening in the market at scale, but what we're hearing may not be what you're living. So it'd be good to hear how you were able to get through COVID. I thought the same exact thing. Well, if you had a bunch of robots that were completely autonomous, who cares if people can get into your factory? Plus, if you have a bunch of trucks that are completely automated and just drive themselves down the highway, then you won't have supply chain issues either.
Outside of Amazon, how many of those vendors are there?
Well, all you need is one massive one. All of this actually really begs the question is, so if with that sort of data, 96% of people, 96% of the companies that were able to respond effectively to the crisis had Industry 4.0, and only 19% who were able to respond effectively didn't have any Industry 4.0. Why is there a gap? Why are we still waiting? Why doesn't everybody have Industry 4.0 installed now?
It's one of these specs that's, and I'm referring to the Industry 4.0 right now. It's at least to me, it's almost as much of an idea as on paper, this is what it is. I sort of have a pretty good idea about it, but if you ask 10 people in our industry what exactly to the letter is Industry 4.0, I don't know if you get anybody who could say, oh yeah, I know, this is exactly what it is. People may say they know what it is, but what it is, and it's nothing new. I mean, I'm gonna say it's 10 years old. If I remember right, it was a National Instruments thing that they developed with a bunch of vendors in Germany about a decade ago. It means having smart industry, having all your machines talk to each other. What was the beginning of IoT at the time, having all that stuff to be able to come together. But if all your systems are all connected, whether it's wirelessly or wired, are you Industry 4.0 compliant? I don't know. I guess you are, right? In the very loose definition of Industry 4.0, that's sort of what it is. I can control this from my laptop on the beach and make sure my factory is running the way it's supposed to, the output's working the way it's supposed to, all machines are up and running. I'm scheduling maintenance for 11:30 tonight on machine number 37. Is that what we think Industry 4.0 is?
It's so conceptual, which is good from the standpoint that you have flexibility because there's so many different use cases. But on the other hand,
that's exactly the bad side. You shouldn't have any flexibility in a spec.
Right. Well, I mean, I don't know if I'd say it's a spec necessarily, but exactly. On the other hand, the problem is it's so conceptual that it's not, nobody knows specifically what it is. If I had to say what it is, what defines whether or not you are an Industry 4.0 enabled company is, especially in the automation sector, can you do predictive maintenance? What you just said. Can I predict when my machine is going to need to be serviced so that it doesn't go down, so that I can avoid any potential downtime? Above that, there are these additional levels. Like, I think that the digital twin example that I used earlier is another level beyond that. You have something that not only can you model your system and then predict when it will need to be serviced, but you can also run simulations of, how will our business fare if this happens or that happens, and how much utilization will I have of my equipment, and et cetera, et cetera. But I think at the very core, it's that ability to do predictive maintenance. And in order to do predictive maintenance, you're going to need a lot of sensors, and you're going to need a lot of edge computing power, installed.
So the bottom line is, hop on board with me, Industry 6.0, and we are good to go.
You can access the McKinsey & Company report, COVID-19, an inflection point for Industry 4.0, online at https://bit.ly/industry40_COVID-19. Now, join Colin O'Flynn of NewAE Technology as he explains the growing risk of side channel attacks and how open source could be the answer to preventing them.
Side channel attacks are interesting because, basically it's like where we leak some information that we didn't intend to reveal something secret. And it's funny when you think about them because, the most classic examples are actually human sort of side channels. The neighbor that's figuring out another neighbor has a mistress or something because they see them leave during the day, is the sort of side channel stuff, right? So some classic like historical examples, not security or not embedded device security, I guess I should say, are things like there's a pizza index, I believe it was called, which was if there's a number of pizza deliveries around Washington really late into the night, it actually kind of coincided with major military offensives because people were working late into the night there. And there were similar ones with the classic like German tank problem of figuring out how many tanks your enemy has by using the fact that the German tanks used a sequential serial number. So if you captured a certain number of tanks, you could actually build this statistical distribution of how many should have existed. So those are kind of the more historical side channels. So when we talk about side channels nowadays, it's a lot of like embedded systems. So what people need to be worried about is where, an attacker has physical access normally to a system. So I guess that's kind of the thing I like to point out early, right, is that most of these side channels, and not all of them require it, but the most sort of damaging ones, I want to say, often require some level of access to a system. So it's a little different from, a computer security malware type risk.
Okay, yes, somebody could do differential power analysis on my whatever. Is somebody going to do that? Like the effort involved in doing that, and the cost involved in doing that, with very few exceptions, is just way out of proportion with whatever benefit.
And so the interesting thing there is you're totally right? So it always depends who you talk to, right? Because you talk to a security person that's like, oh, every single person in the world is going to be murdered by side channels. And then you talk to the silicon vendors that say everything's fine. Right. So there's clearly some in between, but the interesting thing with side channels is actually the defense against it is often don't put secret information in, if you have a little IoT end device, for example, right? If you use the same key everywhere, then someone can do side channel analysis on one device and they've now broken all of the devices. And that's the real risk, which is interesting because, reusing the key is a terrible idea for other reasons, not because of side channel. But side channel is kind of one of those things that's a very specific reason to show not to do that. So that came out because I had looked at some of the early versions of the Philips Hue smart lights, and they basically did that. They used the same key across, in fact, all the products at the time. I don't know if they've changed it now, but it was like, every bulb of the same type, but then even different model numbers of bulbs had the same root key for all their firmware updates. So you could do side channel analysis on one device, which was a lot of effort. But once you had that, you could send firmware updates to the devices and they would gladly accept them, which was pretty interesting because, you could actually take over kind of as many devices as you wanted with that sort of knowledge. As people lock down the first steps, right, of like debug port and stuff like that, now we're really seeing hardware hackers and people looking at devices go to these more advanced attacks. So side channel and fault injection type work. To me, the chip vendors have always known that they could fix or maybe not fix, but improve the security of their chips. But the issue they seem to have is their customers weren't asking for it. And so what seems to be changing now in terms of the market that you see coming out is that chip vendors are starting to push for these higher security devices. And I assume that means because there's the market asking for it. I don't know what the sales look like of these devices and how the pricing differs. But historically, a lot of these defenses were in smart cards for, credit card, satellite TV type thing. You could easily find side channel resistance. You could find fault injection detectors, all this really fancy, expensive R&D terms, hardware that you never saw in commodity microcontrollers. But in the past few years, you definitely see that. So like Silicon Labs has, I think it's Secure Vault, so the EFR32MG21B, which is their higher security device. It's a very consumer microcontroller, right? No NDA, nothing needed. I think there might be parts under NDA, but it advertises lots of these countermeasures, right? That 5 years ago, I don't think you could see a consumer device. Maybe there's a few like that, but it seems like they're starting to become worthwhile.
All of these ARM-based, even down into M0s now, you have Trustzone. It's just a matter of whether or not somebody's using it.
It's interesting you bring up the memory, protection, because that was another really good example that almost every microcontroller, every ARM microcontroller now supports different memory regions. And I had looked at the Trezor Bitcoin wallet, and there was an attack on it using fault injection that worked really well. And basically you did a classic kind of buffer overflow, read past end to buffer attack with fault injection to trigger it. And one of the things that they could have done and would be free, right, is put a trap memory so that in between the data you don't care about and the sensitive data, you have an invalid memory section, and it totally would have prevented the attack, right? And this is just on a standard STM32F2, not a fancy microcontroller per se. But I think it was either configured as one region, or I don't know if it was configured at all. I can't remember at the time. So they added a bunch of that, obviously, to fix it. But it was that's basically a free thing that anyone can do. But it's not too often, to be honest. I see people using that sort of feature.
Right. I mean, we do these surveys all the time, and it's so are you using an ARM-based microcontroller? And I mean, even it's not exclusive to ARM. These types of features are available almost universally now. Yes, we are. Are you using Trustzone or secure device onboard or any of these other built-in security things? No. Why not? Oh, it takes a long time, or I don't understand, it's too complex, or we got to get to market. Those are the answers.
So when I started ChipWhisperer, that was actually one of the big things, is a lot of people didn't care about power analysis at all. They just said it was complicated because there were some really good commercial tools. There's some kind of academic, I want to call them, tools in terms of, MATLAB scripts and stuff that took a bit of effort to put together. So what I kind of wanted to do was give something that an engineer could take and not have to waste a bunch of time, right? Not have to spend half a day figuring out the right version of some library to install and whatever, but to just take it and understand right away, okay, here's how the leakage works, here's what I see. And this is still, I think, where one of the real values of open source especially comes in, is that it allows engineers to see that and to experiment. Because with a lot of these attacks, or with side channel analysis especially, I'd often see people come up with an idea. They say, okay, well, what if I do X? What if I add noise? What if I add timing jitter? Wouldn't that solve it? And most of the time the answer is it doesn't, because the signal is fundamentally still there. But it's a lot more convincing if you can do the experiment yourself and actually try it and then see that. And it's pretty interesting, pretty recent. On the device side, there's been work on open source. So the biggest, kind of most aggressive project is this Open Titan project, which is an open source root of trust, run by Low Risk, and it has a number of partners. Google especially is highly involved to build sort of like a root of trust device in hardware, so like FPGA based, but with an objective, I believe, of making physical silicon out of it, making a chip. Specifically for the Open Titan, I know they've talked about trying to go for a sort of security evaluation, like common criteria rating, like you'd have with a
Mhm.
smart card. And there's a few other ones. So Bunny has this Be Trusted IO project, which is similar. There was an older project, Cryptech, that's still ongoing now, but also was trying to do an open source root of trust. So there's actually, and to me, this is newer, right? Is there's actually sort of devices and designs that seem to be targeting really making a root of trust that someone could use. And the reason it's open source is basically to guarantee what's in it. So the Cryptech project started after Edward Snowden revelations. So there was kind of a question of like, if you really wanted to make sure nothing was fiddled with, basically you need to know everything that's in it. The interesting thing to me is seeing this kind of defensive side of it come out too, and the devices potentially could also be in this open source space, not just the tooling.
Which I guess is a good segue into, if you can explain ChipWhisperer, what its intentions are and how it can be used to bolster, your security foundation and posture.
So I did a PhD on sort of embedded hardware security. As part of that, designed some tooling. So this is where the ChipWhisperer came from. It was this open source tool with hardware, with software, firmware, FPGA design, sort of everything, which was basically designed because it's what I wanted to have to do my own work and to sort of share it with people more directly. And then as part of that, it sort of came the realization that, it's cool having an open source hardware project, but for people to really use it, what I found is they want to just buy it, especially in industry, which sort of led to the setup of the company NewAE. So it's a normal for-profit company, but we really have this mission of making the tooling and knowledge accessible. So, low cost where it can be, but also if it's for more industry, they sometimes need a nicer package, let's say, right, than a PhD student wants. It's been kind of a funny journey because in some ways it's like a gun, right? So it has multiple uses, but it's like if you want to test something, you need some way to do it. And we and I've been pretty careful with ChipWhisperer to make sure it focuses a lot on educational and using for evaluation purposes, which is really one of the points, is to say, like, if people don't care about this, they think it's complicated, it's tooling to help them understand it and use it for testing before someone who's offensive, has the time to look at it. And what it sort of seems like, especially with fault injection, is it's become more common now. So I've seen, other people building tooling, building low-cost tooling, and sort of the, more hardware hacker, hobbyist spectrum. But I'm sure on the commercial side as well, we're starting to see that coming up too. So it's kind of it's a tricky thing, because you really need to show people this vulnerability, which they may or may not want to actually understand that exists. But it's kind of like the hard part of making sure it's as easy as possible for them to understand it, because there's a million, like, side channel is one of the issues, but as you had said, configuring memory or configuring Trustzone, right, is another issue. So there's the engineer only has so much time to figure out where do you put your effort and what's the most critical. So one of the goals was to make that possible, so they can actually do a side channel attack themselves, see what it looks like, and then make a smart decision. Because the issue I sort of saw in this, like in that Philips Hue example, was I'm sure engineers said this was a bad idea, but they had no definitive proof to say, hey, here's how quickly someone could use this to recover a key, right? So if you can give someone that bound to say, this is exactly or roughly what it'll look like, I think then we're making a lot better decisions about where to put your effort.
For more on ChipWhisperer and low-leverage ways of securing your IoT and embedded devices, visit NewAE.com. Up next, Embedded Computing Design's Taryn Engmark enters the wild west of our wireless future. To manage it all, there's a new sheriff in town, ETSI's dynamic reconfigurable intelligent surfaces. There's already a lot going on at the edge of 5G networks, and it's not getting any less crowded. The connectivity technologies flying around at the edge include everything from Wi-Fi and Bluetooth to cellular and sub-gigahertz options. And to accommodate that noisy RF environment a decade or more into the future, engineers at the International Standards Organization ETSI are looking at 6G network architecture options. They may have found a path forward in the form of Reconfigurable Intelligent Surfaces, or RIS. Reconfigurable Intelligent Surfaces are currently being investigated in an industry specification group, or ISG, at ETSI, and although they are not yet well defined, Armand Choujaifard, spokesperson for RIS at ETSI, explains that they can be thought of as software-defined system nodes composed of thousands of small antennas or metamaterial elements that dynamically reshape and control radio signals.
With RIS, we don't actually take the channel as is, rather we turn the channel into a service, something that you can actually program and reconfigure.
RIS can be configured to operate at any part of the radio spectrum, including frequencies from sub-6 GHz to terahertz, and may use tools from artificial intelligence and machine learning to enable systems operation and optimization. RIS represents a paradigm shift compared to the way that networks are designed and built today. That's largely because the nodes don't create their own signals whatsoever. They just recycle and repurpose the signals from elsewhere. While this may sound like an extreme undertaking, it helps solve a key challenge emerging in today's 5G deployments, maintaining coverage within higher frequency bands. By integrating a RIS component onto indoor or outdoor objects, he said,
what you could do is to dynamically control and shape the RF signals in order to improve your coverage performance.
Choujaifard added that these surfaces would have to be made of mostly passive components in order to reduce power consumption and deployment and maintenance costs compared to the fully stacked cells we see today. This semi-passive characteristic would mean that RIS nodes could be deployed onto other objects like walls, and perhaps most importantly, be controlled using a low-power microcontroller. The RIS ISG is currently defining KPIs, deployment and operational scenarios, and other requirements of the reconfigurable networking technology. On the technical front, the working group is currently evaluating RF characteristics of surface models, channel characterization, and radiation exposure limits, as well as the mechanics of RIS-aided air interface technologies. From there, they will look to define system and network control signaling, architectural framework considerations, and baseline evaluation methodologies for the system and link levels. The final leg of the ISG roadmap is standardizing prototyping, verification, and validation methods around a series of hackathons. But the ecosystem isn't waiting for a formal invitation. Early working RIS prototypes are planar surfaces of electromagnetic unit cells that harness some amount of real-time network intelligence to control the cells, executed from a basic microcontroller. Though the ETSI ISG isn't sure exactly when or how we will see RIS nodes deployed, their composition implies that RIS nodes will be everywhere by virtue of being able to interact with basically any RF signal at the edge. RIS won't be a catch-all solution for every wireless networking challenge, but it could fill in a lot of gaps in current networking technology. With RIS, we may finally be able to fully embrace the diversity of the edge.
Thanks for listening to this edition of Embedded Insiders. For daily news, videos, and podcasts, visit our website, embeddedcomputing.com.